Hello everyone, welcome back. So in this problem, we are going to solve this problem, LeetCode 1545. It's saying find kth bit in nth binary string. So let's imagine we are building a binary string that keeps doubling in size, but instead of generating the whole string, you magically jump directly to the kth bit. Sounds impossible, right? But today I'll show you the trick how we are going to solve in a very simple terms. Okay. So very first, what the question saying that we have given two positive integers n and k. The binary string s is getting form how? So s1 is equal to 0 and s1 equal s at I equal to I minus 1 plus 1, and the reverse of invert we are taking, and then it is saying I is greater than 1. Means if we want to create Sn, right, means there will be, let's suppose n stand for some I value, right, there will be some value will be there. So you, when you are going to create this S1, Si you can say, or Sn, right, then the previous value you have to take plus you have to build the, you have to give the string in 1, and then you need to do the reverse. Basically we are building the string recursively, right? It means what I'm trying to say here is, give me 1 second. So let's think again. So how the string is built recursively? So when s1 is there, we are saying okay, it's a 0. Okay, means let's suppose call 0 bit, right? But for n is greater than 1, when n is greater than 1, we just saying that Sn is nothing but s at n minus 1, like that we can say, plus we are saying I, right? And this I is nothing, not I, we can say that is called 1, we can say this is saying 1. And then we'll do the reverse, means we have to do the reverse and invert of this value. It means very first we have to do the reverse, and inside this it should all be the result from the invert, s n minus 1, like that we can say. So this thing saying only if n is greater than 1, means where this reverse is a flip order, right? So if we say reverse means what? The flip order. Okay. And what is this invert? So invert, you know that if we have 0, so 0 becomes what? 1, and 1 becomes 0. That is called invert, right? And the question is saying that what is the kth bit, right? So kth bit we have to find in uh, Sn, right? It's guarantee that k is the valid given n. Okay, so it is little mathematically, but don't worry, we'll try to understand and we'll try to solve this in very simple words. Okay, so let's try to build it. Okay, so there will be a small steps that we can use to understand. I want to build the small case, let's call small case. So let's build the small case. So can we say let's build manually if in the S1 we know that we will get 0, right? When we talk about the S2, means S1 plus we have to add 1 here, right? Plus we have to do the reverse, and then we will do invert the S1, correct? Like that we have to do. It means what? This is 0, this is 1. So if we'll do the invert of S1 is 1, and if we do the reverse, we'll get 1. It means we'll get 0, 1, 1. Like that we will get the binary, right? Then for the S3, we know that S2 is this one, right? And if we want to invert first, right? So to build this one, we should see the invert first. So what is the invert of this one? This value. It is nothing but 1, 0, 0. If you want to do the reverse of this value, what will the reverse, right? So this is 0, 0 and 1, correct? Now let's find S3. So S3 is nothing but what? The very first is the we can say the reverse what you call S2. Very first we'll write the S2. So we'll say 0, 1, 1 means this one we will add. Then we know that we have to add 1. So let's take 1 only. And then the reverse that we have took 0, 0, 1. If we build together, this is 0, 1, 1, 1, 0, 0, 1. Similarly, we'll keep ahead and we'll write S4. So we know that S3 we already have, right? Similarly, we'll build this value and we'll build, let's suppose the very first term is called 0, 1, 1, 1, 0, 0, 1. There will be some value will be there. If we'll take the invert and the reverse, let's think that it's coming something like this. Okay, something it is coming. So you will build this and you will get something here, right? So if you notice something here, what is the observation you are able to see? Just check that. So let's try to understand what we have understood. In step 2, we have gone through building the small cases. We have find S1 string, S2, S3 and S4 and so on. We have find out, right? So there is a little observation. Let's talk about the observation 1. The observation 1. The observation 1 is the length of Sn is 2 to the power n, right, minus 1. Correct? If you see here, when it is 0, it is coming what? S1 is 0. So 2 to the power 0. N minus 1 itself is what? This is n minus 1. It means 2 to the power 1 minus 1 means 2 to the power 0, which is 1. You are getting this. When you are putting 2 to the power n, which is 2 minus 1 means 2 to the power 1, we are not getting nothing but we are getting is 2. Like that we are getting, right? So you have to keep going until you will find this one. So now if you see here, we have 4 and 3, 7, right? It means this is the length of Sn, we can say, and which is coming 2 to the power n minus 1, correct? So 2 to the power n minus 1 we are getting, and so we can say that S1 is 1, S2 is 3, S3 is equal to 7 and S4 equal to 15. Like this we can calculate, right? 2 to the power n minus 1 will say and we'll get these values, correct? So this is not a random, right? This is not random. Now another observation is that observation 2. Let's think. This one is very critical, right? So can we say each Sn looks like what? Let's suppose we have left part we have, right? Left, then we have mid, and then we have right. So this left part is Sn minus 1, correct? and this mid is 1, and this right is very first is reverse, then invert s n minus 1, correct? Like that we can say that. Okay, inverse of this one. What does that mean? If we have divided in these three part, what is the meaning of this? It means the middle will be always 1, right? And the right half, this part is mirrored inward, we can say. Can we say mirror inverted, right? Inverted version of the left half of the of left half, we can say, right? Very first, if you'll find this one, we can invert it, and then because we can reverse it, it means it's a mirror half, right? And that's the entire trick is here. Okay, so let's stop generating the string, because the most beginner try to build the whole string, and that we don't do. So that's a exponential growth will do, because instead of can it ask that where does k lies here, right? So let's try to understand here. So what we are saying in the next step, that we should stop generating the string. We should not do that, because if you'll do that, it will give you the exponential growth, right guys? Okay, sorry. Okay, exponential growth we can say. So that we will not do. Okay, so what we will do, so we have to find where does k lies. Okay, this is the main thing we have here. So we will say that let's find, so length is, if length is 2 to the power n minus 1, we are saying, then mid we will find how is 2 to power n minus 1, correct? So this part we should understand. Now three possibilities here we have, possibilities. Okay, we check the spelling guys. Okay, three possibilities will be there, right? So what are the possibilities are there? So let's say we are saying case 1. So in case 1, if k is equal to mid, right, it means immediately we will return what, 1, right? And that is done. In case 2, right, k is less than mid, it means it lies between what, between the left half, right? So in the left half we can say. That means that means we will say we should find the n minus 1 and the k, right? This is the same problem. This is the same position smaller problem, we can say. This is smaller problem, we can basically we can say, right? Let's check the case 3, where we'll say okay, k is greater than mid. It means now we are in the left part, right? Where we are not left, we are right half, we can say. Now we are in the right half, right? So here what we will get, we will very first we'll do the reverse, and then we'll say invert, and that is s n minus 1, we can say that we can find, like that we can find it. So we here we need, what we need, the mirror index. What we need is mirror index and the invert result. Two things we need. So the mirror formula, how we can find the mirror formula? Let's find the mirror formula. Okay, let's say mirror is the, we have given the length minus k plus 1, right? This will become the mirror formula. It means we can say answer is invert and find n minus 1 comma meter, like that we can say, right? And that's what we need here. This is our answer. So let's try to take this thing with the example. Okay, so what we have found, oh sorry, we have found that we have to generate this string and we'll try to understand, right? So very first we found two observations, right? Observation 1, observation 2, and observation 2 contains uh, three parts: left, mid, and right, like this, where mid is always with there, but the right part is having the uh, mirror of the left half, right? If we want to, if we'll continue generating this generating a string, it will give the exponential growth, where it so the question is, we will stop it or not. We will stop the generating a string and we'll continue, and we'll try to find where does k lies, right? So we'll say, okay, very first we are taking the length n minus 1, we are taking the mid. Now we have three possibilities. When k is at mid, we will return 1. When k is less than mid, it lies in the left half. And then if k is greater than mid, we will go in the right half and we'll find like this. And we need two things: mirror index and the index index invert result. Two things we need, and this is our formula. So we have talked about that this is our formula and this will give you the result, right? Now let's try to understand the with the example. Okay, so we'll say n equal to 4 and k equal to 11 we are taking. So here we'll say, okay, S4 length is 15, and if you want to find the mid, it will get 8, right? So the 11 is greater than 8, it means it will go to the right half, right? It means if you want to the mirror, we'll get, how we will get, just we'll put the value there. So 15 minus 11 plus 1 is nothing but 5. So we will get the, we have got the mirror one, right? Now we have to solve. What now we will solve? Now solve, find 3 and 15. It means S3 length is 7, and so the mid is 4. So we can say 5 is greater than 4, and so it is a right side. It means if you'll find the mirror, we know that we will find 7 minus 5 plus 1 is nothing but 3. Now let's find again. Now find 2 and 3, right? It means S2 having the length is 3, and so we can find the mid here is 2, correct? So 3 is greater than 2, so it will go in the right side. we need to find the mirror. So we'll find the mirror how? 3 minus 3 plus 1, which is 1. Now we need to find what you called 1 and 1, correct? It means we are going to find S1 which is equal to 0, correct? Like that we have to find. So now we have to backtrack it. We have to backtrack the inversion, right? So let's say now backtrack with inversion. We can say invert inversion. Okay. How we'll do that? So if we have a level 2, it means we will invert. It will go 1. If level 3 is there, we'll do the invert. We'll get 0. If level 4 is there, we will do the invert. We'll get 1. So the final answer is 1. Correct? So have you noticed something here? We will never build the string. We just navigate the structure. Okay. I hope you have understood what we have tried to understand. Right? This is the complete example you have. We have two example, n equal to 4, k equal to 1. We found that this is S4, its length is 15. We find the mid, we check it will go to the left half, right? Then we'll find the middle one, because once this is done, we will need to find the middle one. Now we'll solve this 3, 5. It means we need to find the S3, and similarly we'll find the 4. Mid, it is going to the right side because this is right part, right? Similarly we'll find the middle one. Again we'll find the 2, 3. We'll check this is the S2 length. It is going to mid, it is again right. We'll find the middle one. Again we'll find the 1, 1. We are getting S1 is 0. Now we will do the backtracking, right? Like that you will get finally 1. So if we'll talk about the intuition, this is not the string problem, guys. This is a symmetry divide and conquer problem. Recursively you have to recursively you have to recurse the structure exploitation, we can say. And every time you go to the right half, you have to mirror up and you have to flip up. That's what we need to do. So let's try to understand how we'll write the code. Okay, let's go to the code. You will understand clearly. Okay, so what we have given n and k, we have given, right? It means if we write, very first condition is n is equal to 1. We know that what we need to do, we will return 0, right? This is what we have saw, correct? Now if n is not equal to 1, what we need to do, we need to find, let's call, we'll take the length, and it should be, we'll take one left shift with this one, and with the length is, we will find okay, so very first we'll take the left shift and we'll take -1. Then we can say is this one, the length will come, right? We can find easily by this way we can find the length. Then we need to find the mid, right? As we have seen, it means if you have the length, you just need to do +1 by 2. Like this we'll find the mid. Now we'll say if k is at mid, right? If k is at mid, we will return what? 1. We can say that. Okay. If n is equal to 1, we will return 0. If it is at mid, we'll return 1, because mid is always final, right? Then we have checked that if k is less than mid, it means the case is that we have to find the recursively, we have to find the same thing. Let's call the same method, we'll call find kth bit, we can say, where this time n will be reduced to n minus 1. right? And this is k will remain same. So you need to find if k is less than mid, means the left part we are saying, right? Else we'll go to the right half. So the left half and right half concept is there, right? So if it is going to the right half, means very first you need to find the mirror, and we have find the mirror formula. Remember how? If you have the length minus k plus 1, this is the formula we have seen, correct? Then we have to find a char bit, we can say. What is the character bit we have here? So we'll use the same formula, find we'll use the same recursively we have to find, right? So again we'll find n minus 1 the mirror one. What we find in the mirror formula, right? That we will find the mirror. After that you will return the bit as if it is equal to, let's call is 0. If the character bit is coming 0, it means we will say 1 or we'll say 0, we can say something like that we will say. Okay, let's try to run. Try to submit. Yeah, so it's working. Okay guys, okay, so as you can see, we have first we have checked the condition. If n equal to 1, we return 0. Then we'll find the length and mid. If the k is at mid, we'll return 1. Otherwise we'll check if it is in the left half or in the right half. If it is in the right half, we'll find the mirror using the formula length minus k plus 1. Otherwise we'll find the what is the character bit is coming, right? Using the n minus 1 mirror, it will keep recursively it will find, right, the bit, character bit, right? Because see, this I told you the intuition is not a string problem. It's a kind of symmetry. It's divide and conquer. A recursively you have to recursive structure exploitation you have to do, right? And every time you go to the right half, you have the mirror and you have to flip it, right? That's what we have to do, guys. Okay, so what is the time complexity and space complexity here? Because each recursive call will reduce n by 1, right? It means the time complexity will go to O of n. Okay, and for a space complexity it is also O of n, because we are doing the recursive call, right? But it's efficient, very efficient code we have. And if you have any doubt, please ping me in the comment box and let me know in the comment section that you understood or not. And if you have any suggestion, please ping me in the comment box. That's all I have in this video, guys. Thank you so much. Thank you for watching this video.
Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.